Review of factoring. In our first example, we wish to factor the following polynomial, 2x to the fifth minus 8x to the third. Remember that factoring is a sort of reverse procedure from multiplication. So we have to ask ourselves, what will we multiply to be able to get this polynomial? And so there are several factoring techniques. The first one is called the greatest common factor. So when we say greatest common factor, or GCF, what we mean is what is the largest thing that divides evenly into both of these terms of the polynomial. So we know that if we look at the numbers 2 and 8, the largest number that divides into both of these numbers evenly is 2. And then for x to the fifth and x to the third, the largest quantity that divides into those evenly is x to the third. So that means the greatest common factor in this case is 2x to the third. Now what we're going to do is we're going to factor out 2x to the third out of each of these. So what you can do is you can take your expression 2x to the fifth minus 8x to the third, and you can write it as a product of 2x to the third and something else. So for example, 2x to the fifth we know is 2x to the third multiplied by x squared. And then 8x to the third is 2x to the third multiplied by 4. And so now you can see that the 2x to the third power is the greatest common factor, and then we can pull that out, right? Using the distributive property, we can pull that out, and then what we have left over is x squared minus 4, okay? So this is factoring by using the greatest common factor. Now, once you get done with that, you need to look at what's left over and ask, can this also be factored? And so x squared minus 4, you might remember from elementary algebra, this is the difference of two squares, and it too can be factored. And so x squared minus 4 ends up being x minus 2 times x plus 2. So if you multiply this out, you will get x squared minus 4. And so our final answer here is 2x cubed times x minus 2 times x plus 2. Now in our second example, it's actually almost exactly the same problem. So the greatest common factor here is once again 2x to the third power. And I'm going to factor out 2x to the third power out of each of those. Now when I do that, of course, out of the first term there, I'm going to get x squared. Now we have plus, and then when I pull 2x cubed out of here, I'm going to get 4. So it's exactly the same process. The only difference is now we have x squared plus 4 left over as opposed to x squared minus 4. Now x squared plus 4 is the sum of two squares. And the sum of two squares is not factorable, at least not over the real numbers. So for right now, we're going to say this is done. And I say for right now because later on in this course, we will learn how to factor x squared plus 4. But for now, it's not factorable any further. In our next example, factor 3x to the fourth minus 18x to the third plus 27x squared. Again, we need to identify the greatest common factor. So if you look at 3, 18, and 27, we can definitely factor out a 3. And then for the x's, when you have a bunch of powers of x, the greatest common factor is going to be the lowest power of x. So it's 3x squared. So if I pull 3x squared out of x to the fourth, we get x squared. If I pull it out of 18x to the third, we get negative 6x there. And then finally, positive 9. Okay? Now we look at x squared minus 6x plus 9, and we have to ask, can we factor this? And the answer here is yes. Now, this is trinomial factoring. In this case, it's fairly straightforward. It's x minus 3 times x minus 3. Note that if you multiply x minus 3 by itself using the FOIL process, you will end up getting x squared minus 6x plus 9. Okay? So because we know we can multiply this to get this, we know that this factors into x minus 3 times x minus 3. Now, in just a minute here, I'm going to talk about another factoring technique called the magic X, but this one here, like I say, is pretty straightforward. Now, one final thing we can do for this problem is, since we have x minus 3 twice, we can write that as x minus 3 quantity squared. Okay, so in this example, we are factoring 6a squared minus 11a plus 4. Notice that in this problem, there is no greatest common factor. In other words, the greatest common factor is equal to 1. So it doesn't do us any good to factor out 1. So we need to go straight into the trinomial factoring techniques. Now, one way to factor trinomials like this is just to use trial and error. So in other words, if I just take 6a squared minus 11a plus 4, I just think to myself, what could I possibly multiply to get this? And then you start brainstorming. So for the number 6 here, we know that 6 is equal to 1 times 6, or 6 is equal to 2 times 3. So in terms of 6a squared, we could either have 1a times 6a, or we could have 2a times 3a. Now, how do we know which one is going to work? Well, we really don't until we start considering the other number at the other end, which is 4, which is 4 times 1, or 2 times 2. And the numbers that we select here have to work in conjunction with the numbers that we select here to make the negative 11a in the middle. So one way to do this is to just try things. So for example, I could try 6a multiplied by 1a, and then 4 could be 1 times 4, let's say. Now, the signs here, we'll leave the signs blank for a minute, but notice that if I multiply 6a times a, I do get 6a squared. 6a times 4 is 24a, and then 1 times a is 1a, and finally 1 times 4 is 4. But does this have any chance of making negative 11a in the middle? Regardless of what the signs are here, positives or negatives, am I going to be able to make negative 11a in the middle? And the answer is no. 24a and 1a will never make negative 11a when you add these together. So this is not the correct combination, okay? Now, you can keep on trying different combinations until you get there, or you can use a different technique, a technique that I call the magic X technique. Let me show you how that works. So for the magic X, we are going to draw a large X here. And we're going to multiply these two numbers together. So 6 times 4 is 24. And then the middle number here, negative 11, I'm going to put that in the bottom of the X there, okay? Now what I'm going to do is think about what numbers can I multiply to get positive 24, and the same two numbers I can add to get negative 11. Now if you think about 24 and all the different factors, the ones that stick out to me when I look at this are 3 and 8. I know that 3 plus 8 is 11, but how do I make it negative 11, and how do I get positive 24? Well, the answer is pretty straightforward. We're going to have negative 3 times negative 8 gives us positive 24, and negative 3 plus negative 8 gives us negative 11, okay? So it's the product of these two numbers that gives us the top number, and it's the sum of these two numbers that gives us the bottom number, all right? So we have found the numbers that work. Now we have to actually do the factoring process. Now the factoring process is a little bit tricky. So we're going to start by just putting an A and an A. Now we know that this is not right because A times A is A squared, and we need 6A squared. But let's just be patient for a minute. Then I'm going to take both of these numbers and put them in here. So minus 3 and minus 8. And then the super important step is we have to identify the leading coefficient of a squared, which is 6, and I have to divide each of these by 6. Okay, so I'm going to divide this by 6 and this by 6. Next step, I'm going to reduce. So 3 divided by 6 is the same as negative 1/2. And 8 divided by 6 is 4/3, or negative 4/3 in this case. Once I have those reduced, the last step is very simple. We take this denominator here and we move it in front here. Same thing on the other one. And when we do that, we end up getting 2a minus 1 multiplied by 3a minus 4. And I will leave it to you, but if you multiply this out, you will see that you end up getting exactly what you had in the beginning. And this is what we call the magic X method. Now, in our next example, you'll notice that it's very similar to the previous example. The only thing that's different, in fact, is this is a negative 4 instead of a positive 4. But that changes everything. So, first we are going to multiply 6 times negative 4, which is negative 24. And then we have negative 11 in the middle. And now we have to try to identify factors of negative 24 that we can add together to get negative 11. So let's think about this for a minute. So here are the possibilities once again. Now remember, we have to multiply to get negative 24. So you might think that we could use negative 3 and negative 8 because we know that those add up to give us negative 11. But if you multiply negative 3 times negative 8, you get positive 24. Okay, so that's not going to work. Well, to make this negative 24, I could turn negative 8 into positive 8, for example. Negative 3 times 8 would be negative 24, but now when I add these together, I don't get negative 11, okay? So 3 and 8 are not going to work. Even if you tried putting, the negative on this side, it's still not going to add up to negative 11. Now, of course, 4 and 6 also don't work because 4 and 6 don't make 11. 2 and 12 don't make 11. And 1 and 24 don't make 11. So there are no possibilities that work for this, okay? So in this case, we say that this polynomial is prime, all right? It does not factor. Now, in truth, all polynomials factor, but to factor this polynomial, we would have to use something called complex numbers or irrational numbers, right? And when we factor polynomials, we usually only think of factoring with rational numbers, okay? More specifically, integers. So this does not factor, at least for now. All right, in our next example, we have 2x to the fourth plus 16x. Once again, we do have a greatest common factor here. In this case, the greatest common factor is 2x. So we can factor out the 2x, and we're going to have x to the third plus 8 left over. Now the question is, can we factor x to the third plus 8? And the answer is yes. This is the sum of two cubes, which is something that probably you have heard of at some point in an algebra class, but I will remind you how it works. So if I have a to the third power plus b to the third power, the way this factors, very simply, is we're going to have a plus b as the first factor. So basically just ignore the cubes here. And then in here, we'll have a trinomial. The first term here, you're just going to square this. So a squared goes there. The last term over here, you're just going to square this. So if we square b, we get b squared. And then in the middle, we are simply going to multiply these together. So a times b is ab. And then in terms of the sign, whatever sign you have here, the opposite sign goes here. So that's going to be a negative. And the last sign is always positive, okay? So this sign here is always positive no matter what. Now there's also a difference of two cubes, and it works exactly the same way. But the only difference is, since a difference of two cubes has a minus sign here, you will start with a minus sign here, and then this sign is the opposite of that, which is a positive, and again, the last term is always positive here. So these are the cube formulas, sum of two cubes and difference of two cubes. So in this problem up here, what I need to do is simply recognize that x cubed plus 8 is x cubed plus 2 cubed. And then when I go to factor it, it's just going to be x plus 2. And then I square x to get x squared. I multiply 2 times x together to get 2x. And that sign is going to be a negative. And then 2 squared is 4. So I have positive 4 on the end. And this is the complete factorization. And one nice thing about using the sum or difference of two cubes is you don't have to worry about factoring the trinomial here that's left over. All right, in our next example, we have a multivariable polynomial. I want you to notice that there is a greatest common factor here. We can factor out a 2. We can also factor out an a, and we can factor out a b cubed. So our greatest common factor is 2ab to the third power. If I factor that out of the first term, we're going to have b squared left over, right? Because if I pull 3 b's out of 5, I have 2 left over. Here I will have a positive 4b and then a positive 1. Okay? And once again, if you attempt to factor this using a magic X, you will see that this is not factorable. So this is the only factoring that we can do in this problem. In our next example, we're going to talk about a factoring technique called grouping. So in this problem, notice that we have 4 terms. We have 4x squared minus 6x plus 2a times x minus 3a. And what I can do here is notice there's no greatest common factor among all 4 terms. But what I can do is I can think of these 2 terms as being a problem and these 2 terms as being a problem. So if I were only focused on these 2 terms, I would be able to factor out a 2x here. So if I pull out that 2x, what I'm going to have left over is 2x minus 3. Okay? So I just pulled the greatest common factor out of these 2 terms. And then if you look at the next 2 terms, what can you pull out of there? Well, the only thing these 2 terms have in common is an a. So I can pull out a positive a, and when I do that, notice what's left over. You have 2x minus 3. So this is a success because notice that you have 2x minus 3 written twice here. So now this polynomial has essentially 2 terms. You have this term here and this term here. And out of those 2 terms, they have a common factor of 2x minus 3. So I'm going to pull that out, and then what I have left over is simply 2x plus a. And that's it. In our next example, we have a higher degree polynomial, 4x to the 4th minus 35x squared minus 9. Now, you can use trial and error to do this, but the main thing we need to talk about is what do you do about these higher powers? Well, in this case, it's pretty easy to deal with these higher powers because x to the 4th comes from x squared times x squared. So let's just make that observation. And what you have in the middle is an x squared. So you can basically factor this like you factored the rest of your polynomials, your trinomials, I should say. So I'm just going to make a magic X. And I'm going to multiply these together. So 4 times negative 9 is negative 36. And in the middle, I have negative 35. And now let's just think about what numbers can you multiply to get negative 36 and add to get negative 35? Well, out of all of these possibilities, the only numbers that we can add or subtract to get 35 would be 1 and 36. So we kind of know that we're going to have to use 1 and 36, but we have to have negative 36 and positive 1 because when I add these, I need to get negative 35. And also when I multiply them, I have to get negative 36. Now, once I have those, when I go to do the actual factoring, I'm just going to do x squared and x squared. Okay, and then we bring over the positive 1 and the negative 36. But then remember, whatever number you have in front here, you have to divide each of these by that number. That's kind of the trick of the trade here. Now, notice that 1/4 does not reduce. So this 4 is simply going to go in front here. So that becomes 4x squared plus 1. But 36 divided by 4 here, this does reduce. So if it reduces, make sure you reduce it. So that becomes x squared minus 9. And then we just ask ourselves, can we factor this anymore? The answer is no. This is the sum of two squares, so this stays. But x squared minus 9 can be factored into x minus 3 times x plus 3. Once again, that's a difference of two squares. And this is the complete factorization. And for our final example, we have sort of a strange looking expression here. This polynomial has three terms. We have a term here, a term here, and a term here. And notice that all three of these terms have an x minus 3 in it. So I can pull out that x minus 3. And what I have left over after doing that is 2x squared minus 5x minus 3, okay? And then the question is, can we factor this? And the answer is yes, I think. Let's make a magic x. Let's multiply 2 times negative 3, which is negative 6, and then the middle number is negative 5. What numbers do I multiply to get negative 6 and add to get negative 5? Negative 6 and positive 1. So this one right here should factor x minus 6, x plus 1, but don't forget you have to divide by 2 on each of those. And so this becomes x minus 3, and this one becomes 2x plus 1, right? This 2 has to go up here, and this one reduces. Okay, and then after all that, don't forget you also have to bring down this other factor of x minus 3 that we had to begin with. So our final factorization here is x minus 3 squared times 2x plus 1. And that concludes this video lesson.